Hey, I'm Pat, and in this video I will be going over using Fastcast in Roblox Studio. This is a open sourced module script that is very useful for making projectiles with accurate raycast hitboxes, as well as doing things like bullet drop, things like that. It's mostly just for projectiles. That's the most useful thing because it allows you to give it acceleration to pretty much simulate bullet drop, or you could do wall piercing and other things as well. Of course, bullet travel speed, velocity, whatever. So the first thing is you're going to go to the toolbox and you're going to get Fastcast. You can find it on the dev forum as well, but this is the module you want to use, Fastcast Redux by Zan, and we'll go ahead and get that. And you can put it anywhere. Replicated storage is a pretty good place. Usually I have a folder called dependencies, which will have all my module scripts, all my module scripts I'm using for that game pretty much. Not all of them, but like, the open sourced ones that I'm using. Well, what I'm going to do is I'm going to make like a little cannon thing, and that's what we're going to be making. We're going to be making a nice little cannon buddy. So it's going to be a pretty basic cannon. We're just going to click our part, and then a cannonball will launch out of here, and it'll go in an arc pretty much. So let me get an arc part here. We'll get a sphere. This will be our little cannonball, and we can even make it look like a cannonball more. Maybe something like that. There we go. There's our cannonball. Alright, so we'll call this cannonball, and we'll just put this in replicated storage. So let's actually get into using Fastcast and how it works, because that's kind of important. So I'm going to make a server script here. Let me actually make this into a model. We'll call this clicker. This will be our barrel. I'm actually going to put an attachment inside of our barrel, and this is actually kind of important because this will give us a good location for us to spawn in the cannonball at. So I'm going to put it roughly in the middle if I can get it there. That's pretty much it right there. So we'll spawn the cannonball in right at this attachment, so that way we don't have to spawn it actually in the middle of the barrel, because that's where the anchor point is for it. That's where the position is. It's right inside the middle. So instead we'll use the attachment. Alright, so click detector, let's have our clicker. We'll get our cannon, and what we'll also need is Fastcast, obviously. So we'll get replicated storage just because we're going to reference it a few times here. rep.dependencies.fastcast redux, and we're going to have to require it. Something I forget to do sometimes. And then we'll get our cannonball. Or not Fastcast, rep.cannonball. Alright, so the way Fastcast works is you create a caster object with Fastcast. So you use fastcast.new to make a new caster object, and I believe it doesn't actually take any parameters. Right, it's just no parameter or no arguments. It's just empty, and this will give you your caster object, which will host all of your events. So your caster object has multiple events. So we have length changed, which fires obviously whenever the length is changed for the projectile. And we also have caster.rayHit, which obviously is when it hits something. There's also ray pierce for obviously if you're doing piercing through like different materials and things like that. you could listen on the ray pierce event and maybe like emit a little particle or create a hole in the wall where you pierced or whatever. And we also got caster dot cast terminating. We're not gonna need that. We just need ray hit and the length change for our camera roll, really. So obviously these are all gonna have a bunch of different arguments. So I'm just gonna copy most of it from the API, which I'm gonna have linked in the description, of course. So it's going to give us the active cast, the last point it was at, the ray direction, displacement. I'm not sure what displacement is supposed to be. Segment velocity and instance cosmetic. This is the bullet object that we're going to be using, obviously. And then we also got ray hit, which I'm going to get the parameters for that. And you got the active cast, the ray cast result, which obviously is pretty important, velocity, and the bullet object, so that way you can destroy the bullet object after you hit something. Or if you want to have a custom way of getting rid of it, you know, you can do it that way. Maybe you have object pooling or something. And on the API, it actually gives you the formula to position your bullet object. So you're going to actually be using the length changed event to position your bullet object. It doesn't automatically position the object for you, and you think that's kind of stupid, but it's actually pretty useful because let's say you have a bullet object that faces a certain way, like let's see this. So the face is here, or not here, it's right here, right? That's the face, that's the front face of the part. But let's say we have maybe like, imagine this is like a projectile and we want this to be the face, but this side's actually the face. What we can do is inside of here is we can actually offset the C-frame with like C-frame.angles, and we can rotate it so that it's facing frontwards even though that this is the front face. You see what I'm saying? So you can kind of position it however you want inside of here, no matter what the projectile is, which gives you a lot more freedom. So it's actually pretty important to have. So we're going to be using last point. So local new pause. So we're going to make a variable called new position, and this is just going to be using our formula here, which I just took off of the API, nothing complicated. And then cosmetic bullet object dot position equals new pause. I believe this is going to be a position. Yeah, this should be a vector 3. You could also make this into a C-frame if you want. Whatever. It's not too important here since our cannonball is round, so we don't have to like worry about orientation or anything like that. Alright, so that's our length changed, and now ray hit. What we can do is on our ray hit, we can actually create a little explosion. So we'll make an explosion. Instance.new explosion. Yeah, that's how you spell explosion. It's fine. So explosion dot I don't know much about explosions, gonna be honest. Blast radius. Is this a number? Blast radius 60, yeah, it's a number. Radius equals 40, sure. Explosion dot position equals, and we'll use our raycast result for this. Raycast result dot position. So we'll just position it right to our raycast results position, and then we'll parent it to workspace. And explosion dot oh, there's a hit? I didn't even know that. I don't even know. I don't think it has automatic garbage collection. We'll just do game get service debris, add item, explosion, and we'll give it like 0.2 seconds. Alright, and then we'll also obviously want to destroy our cosmetic bullet object. Now obviously you could use type check in here for give you a bit more IntelliSense. I'm not too concerned about that right now because we're not doing anything crazy. So whenever our projectile's length changes, we're going to position it to the new position, and then once it collides with something, we are going to create a little explosion and destroy the bullet object. So nothing too complicated. We're not even really doing damage. We could if we want to, but I'm not going to worry about that right now. So now what we got to do is I'm going to actually move this back up here. This should be up here. And then we're going to reference our clicker, or our click detector, Canon.clicker, that click detector at mouse button 1 click, or mouse click, whatever. So now what we'll do is we'll listen to whenever the player clicks, and now what we'll have to do is obviously we're going to have to create our actual raycast or whatever. So the way we'll do that is, let me think of some, hold on. Let me think. So we're going to need to figure out which way is going to be the front. So we'll actually just use this clicker. We'll use the direction of this. Or maybe we'll go up. Maybe we will just use the direction of this part. Maybe that is the face. Yeah, I think I'll just use the face of that. So, caster, let me figure out how to do this. I forget how to actually cast. I don't use this often enough to have it memorized, but I'm really close to having it memorized. Why can't I find... Alright, well, what we're going to need as well is behavior for our projectile. Local behavior equals fastcast.new behavior, and this will return a table which has a bunch of different things. So we have our raycast parameters, so we'll know what to ignore, and obviously this is going to be our Canon, so we'll actually make raycast params for that. Obviously it's going to be just your normal raycast parameters, nothing special. Filter type equals filter type raycast filter type dot blacklist. Filter descendant instances equals, and we'll just put our Canon in there, and then we gotta set it for our behavior. So behavior and raycast params just equals our parameters, and then behavior dot acceleration. What we're gonna do is we're going to make this a vector3 dot new. Actually, what I might do, I think I'll get our goal position here, just because it doesn't matter too much. So we'll actually use our, alright, you know what, I'm not going to go too crazy. I'm just going to make its acceleration negative on the Y. So we'll give it a negative acceleration, maybe like 50 on the Y, and then X and Z are going to be 0. Now something you have to take into account is if you're doing acceleration on the X and Z, you have to make sure that the position is correct, right? It's not going to be based off of the orientation of the bullet or like the direction of the raycast. It's going to be based off of the world's axis, so it's not going to be so you're going to have to multiply it basically by a unit vector if you want it to go a specific direction, if you want to go that route. But for the y-axis, it's not actually that complicated. You can set its max distance here. I don't think that's going to be necessary since we have enough bullet drop that it should hit something in any case. Auto ignore container, which will pretty much say that it'll ignore the container, obviously. I think this is defaulted to true, but I'll just make sure it's true anyways. And then now we have to pick out our cosmetic bullet template, which is going to be rep.cannonball. That's going to be our projectile, our cosmetic bullet template, so it's going to be using that. And something you can also do is set the container for the projectile. So say you have a folder inside a workspace for all your projectiles or something like that. You can make it so it parents all of its projectiles to there using the container like this. So workspace dot projectiles, we'll just reference that. And now behavior, anything else? I believe, yeah, you can also do the cam pierce function and things like that. The thing behind this is you can set a custom function for your pierce, which will return true or false, whether or not you want it to pierce. And the reason for that is you can pretty much do things like calculate how big the object is, like the size of the wall that you're piercing or the material that it has and things like that. and use that to determine whether or not you want to allow the bullet to pierce it. So it's actually really useful for that. That's really cool. High fidelity behavior. Nothing else that we need here, I believe. That should be all. So now we got our behavior, and now I just have to try and figure out if I can remember how to actually, like, their API is a little confusing, I'm not gonna lie, guys. Caster, it should be in here. Caster fire, yeah, here it is. Alright, so then all you do is you just use the fire method. So caster fire, it even autofills for me. I don't know why I didn't just try that before, but so you're going to use the origin, direction, and the velocity. Now something you want to keep in mind is direction is not the same thing as the direction for raycast. You're going to mostly want this to be a unit vector. I believe they're going to dot unit it anyways, but this is just going to be your direction. It's nothing more than that. It's not telling them how far to go or anything like that, because you're going to have a velocity telling, you know, which speed to go at. You're going to have acceleration, and you got the max distance with behavior, so you don't need to determine the you get it you don't need to determine this distance there. So we'll put our behavior here. Our velocity, it can actually either be a vector 3 or a number, but our velocity is just going to be a vector 3. Actually, we'll just use a number here. We'll do maybe 200. This direction, we're gonna have to use the cannon for our direction. So what we're gonna do is we're gonna get maybe like 100. We'll go like 50 studs. So local goal pause cannon dot barrel dot C frame dot new. So we'll go 50 studs in front of our barrel's front face for our goal pause, and then our direction will just be cannon.barrel.position. Actually, I might get this backwards first try, so we'll see if we get this. And goal pause.position.unit, and then we got the that's all we need there. It's just the direction out of that. And now the last thing is our origin, which is going to be cannon.barrel.attachment, and then we're going to use its world position, because that gives us its actual world position, not the relative position to its parent for the attachment. And this should work. I might have the unit backwards, and I might get an error first try, who knows, but we'll see. Yes, I forgot to anchor it. That's great. I believe you don't actually have to anchor your projectile, but it is a good practice to anchor it, turn off can collide, can query, can touch, and all that, because that will actually make it a lot more performant if you turn off, you know, these three and anchored, or make sure it's anchored, because it doesn't actually need to detect the collisions. The projectile and collisions are completely separate. It's raycasting, and it's just moving the part along the raycast. It's not using the part for collision detection at all, so you don't have to worry about that. Let's see if Studio wants to work. I don't know why. It just decided to not work there, but alright, so we'll try now. That's great. So for some reason it didn't ignore the cannon. I don't know why it did that. Oh, it might have hit the base plate. This might actually be backwards, actually, now that I'm thinking about it. So we're gonna go ahead and reverse it. It might have went backwards and hit the base plate. That's my assumption, but I could be wrong. There we go. And you see, it has a nice bullet drop arc, and eventually, boom. Obviously, it goes a lot further than I thought it was going to, but you know, it works as intended. You know, it goes into the sky, has an arc, has a velocity, it changes over time, and if it hits something, it blows up. You can see I hit myself and I blow up. Pretty cool. So that's really it for fast casting. It's not too complicated to use. It's pretty useful. I use it a lot. I really like fast cast. Anybody that knows me knows that I love fast cast. But yeah, that's pretty much it for this video. Hopefully it helped you understand fast cast a little bit better. It's very useful to know. Yeah.